Now the SQL Server joins. They are used to combine two or more rows based on the related column between them. So joins helps in fetching data that exists in multiple tables, and they are crucial for relational database operation. All right, so we have the inner join. So the inner join returns the rows where there is at least one match in both tables. And then the left join, or the left outer join, it returns all the rows from the left side and the match rows from the right table. If there is no match, then the result is null on the right hand side. And then right join, or right outer join, it returns all the rows from the right table and the matched rows from the left table. So if there is no match, the result is null on left. And then full outer join, it returns rows where there is a match in one of the tables. And then we've got the cross join. It returns a Cartesian product of two tables. So it joins every row of the first table with every row of the second table. All right. So now let's see if we can do some examples there. So suppose, let's say we have another table called employee orders that records which employee handled which order, and we want to find out the names of the employees who handled orders. So we will quickly create a table, employee orders. And in the table, we don't really need a lot of things. So we're going to have employee ID, which is the integer. And then we're going to have the order ID, which is also the integer there. All right, now let's insert some hypothetical data. So we can say insert into the employee orders, and then we want to insert the employee ID, and then the order ID. And then of course the values, let's say it's 1 1, and then 2 3, excuse me, and then 2 3, and then let's say 1 4. All right, so and then what we want to do is to select, so we're joining the employee orders with the employees table. So we're going to say select e dot first name, and then e dot last name, and then o dot a order ID, and then o dot order date from employees e. And let's just fix a little errors there. Just wanna make this nicely there, and then just make sure that this is correct as well. Okay, so I've got employee. I suppose that's why it was sort of okay. And then we're gonna use inner join employee orders. Let's give it an alias of EO for employee orders, and then on E dot um, employee ID. ID, where is EO dot employee ID. When do we have an employee ID there on? And then inner join orders O on EO dot the order ID, where is O dot order ID. This query will return only the rows where there is a match in both the employee and the orders table through the employee orders table. So if the employee has not handled any orders, or if the order was not handled by any employee, then those records will not appear in the result set. Okay, I see here it doesn't see the employee ID, so I'm not sure if I didn't. Let's just see. Let's just check when we were creating. I think it's this one. Probably is the first one. Employee. Okay, so that's a problem. We never really put the employee ID. Alter table employees, and then we add employee ID, which is int identity. Just gonna use identity now, and it's also a primary key. All right, so we can execute this. All right, hopefully it will assign the existing data. It will assign the IDs on the existing data. I'm just hoping so. And then we can actually go back here and where is that one now? Alter employee ID, which is fine on the employees, yeah. Just make sure that we have the same spelling as well. So let's execute this one. There we go. So it actually works. All right. So it actually works fine. Now you can actually see so it returns the rows where there's a match in both employees and the orders table through the employee order table. So if the employee has not handled any orders, or if the order was not handled by any employee, those records will not appear in the result set. So if an employee 1, for example, John Doe, handled orders 1 and 4, and then employee 2, Jane Doe, handled orders 3, then the result would actually list these 3 associations, all right, excluding the employees without any orders, and orders without an employee handler as well. Now this is just the inner join. Understanding these joins is crucial for data manipulation and analysis as well in a relational database. Now we've already talked about the inner join. It returns only the rows where there is at least one match in both of the tables that is being joined. So in this example, we wanted to find out the names of the employees who has handled the orders using the employee table. We've joined it with the um, employee orders table, which links the employee to the orders they've handled. Um, Now, in the SQL statement that we see here, it returns only the rows where there's a matching employee ID in both employees and the employees orders um, table, and matching order ID in both employees orders and orders table. Now, employees without orders and orders without an employee handler are excluded from the result. Okay, now let's talk about the left join before we can actually do the example. Now, the left join returns all the rows from the left table and the matched records from the right table. For the rows in the left table that have no match in the right table, so the result will contain null for the right table columns. Now, let's say we want to list all employees and any others that they might have handled, so including those that haven't, done any orders before. So we're gonna just switch this to left. You can just switch this to actually left. Now, I want you to notice the difference here. Now, for the employees that don't have any orders, it actually returned null. Whereas the inner join, it excluded anyone that didn't have any orders. So every employee is listed in the results. So if an employee has not handled any orders, then the corresponding order ID and the order date values, they're actually outputting null there. So that is the left join. And then the right join will be the opposite of the left join. So the right join will return all the rows from the right table and the match records from the left table for the rows in the right table that have no match in the left table. The result will contain null for the left table columns. All right. Now let's say we want to list a let's say we want to list the orders and the employee who might have handled them, including the orders that when handled. So I'm just gonna type this in a new query. So we can say select let's say employee dot first name e dot first name e dot last name, and then we actually looking for the o dot order ID, and then the o dot order date, order date, and then from orders o, and then left join employee orders, um, employee orders on order ID, where is eo dot order ID, and then left join employees e on eo dot employee ID, where is e dot employee ID. Now, if we are missing a comma here, I was wondering where that line Where is it coming from? There we go. All right, so if we execute this, now you can actually see that the orders that does not have anyone, then it's actually it's returning now. Like I said, it's just said the right join is the opposite of the left join. So every order is listed in the result, but if an order has not been handled by any employee, then the corresponding first name and last name values in the output will be null. Then we've got another type of a join called a full join or full outer join. Now, full join, it returns rows where there is a match in either the left table or the right table or both. And then for the rows that do not have any match in the opposite table, the result will contain null for the column of the table without a match. All right, so let's say we want to get the list of employees and orders showing who handled what, including the employees who didn't handle any orders and orders that went handled by any employee. So we will actually write a SQL statement like this. Select, let me just do this. It's a Monday, so I'm actually lazy to type, so I'm just gonna copy. Um, so we select that, and then from, let me just make space here, and we can actually do this. Select from employees E, and then we can just say full join employee orders on e dot employee ID, where is a eo dot employee ID. And then we can do the same with the other table for join orders o, and then on eo dot order employee ID, and then where actually sorry order ID where is o dot order ID. Now if we go ahead and execute, then we can actually see it returns everything except that it will the result actually also return now for the columns of the tables without a match. Now the results include all the employees and the orders where there's no match. For example, an employee who hasn't handled any orders, or that or an order that wasn't handled by any employee, then you can actually see if I scroll down, then that order will return null, or the employee that haven't handled any order, it will also return null. All right, then we've got the cross join. So the cross join returns some sort of a Cartesian products of the row from the tables that is being joined. Essentially, it joins every row of the table with every row of the second table. Now, let's say we want to generate a list pairing each employee with each product, which could be a hypothetical, for example, a hypothetical scenario for assignments or interest. So we will actually do something. I'm gonna just add a new query here. We can say select a first name and then e dot last name, and then p dot product name from employees then we will cross join with products. Excuse my spelling here. It's first name. All right. So basically, this query here, um, it produces a result set that includes every possible combination of the employees and the products. So if there are maybe 5 employees and 4 products, the result will have 20 rows, 5 employees multiplied by 4 products. Okay, so each join type serves a different data retrieval needs, from strictly matching the criteria using the inner join to a exhaustive combination using the cross join. So it just provides flexibility in how the data is combined and how it's reported from the relational database.